The science behind a PET scan. Hi, and welcome back. This video series will help you understand step by step how a PET scan works. Make sure to watch the videos in the correct order, as the information in each video builds upon the previous ones. Here you can see the journey we are on to understand the science behind a PET scan. In the introduction video, we talked about what a PET scanner is. In this video, we'll go back to the basics and learn about the atom, because PET scans wouldn't exist if it weren't for the atom. In the following videos, we'll continue with radioactive decay, the synthesis of the radioactive tracer, and finally, we'll look at the creation and analysis of the images. The other videos are linked in the description box down below, so if you've already seen this one or you've skipped the introduction video, make sure to check out the others. Today, we will learn all about the atom. We'll start with the most important characteristics of an atom. Next, we'll discuss the different particles an atom is made up of. Then I'll show you a size comparison to give you an idea of the atom's true size. Afterwards, we'll briefly discuss the strong nuclear force. Finally, we'll summarize the most important concepts we talked about, the ones you should keep in mind. So, what is an atom exactly? Atoms are the basic building blocks of everything. As Richard Feynman, one of the most famous physicists of the 20th century, wrote in the introduction to his lectures, all things are made of atoms. So, everything we see and touch, regardless if fluid, gaseous, or solid, is made of atoms. For instance, the air around you, your hand, the water in your cup, and even the screen you're looking at right now. They are all made of atoms. Atoms are not visible to the human eye because they are really small. To understand just how small an atom truly is, I will show you a size comparison. But first, a bit of history. Did you know that even the ancient Greeks already had a concept of the atom? The word atom comes from the Greek word atomos, which means indivisible. But thanks to today's science, we now know that the atom can, in fact, be divided into smaller particles. Let's take a closer look. These particles are called subatomic particles. The center of an atom is called the nucleus and is made up of nucleons. Nucleons can either be protons or neutrons. They are tightly packed together, forming the nucleus. Here, the nucleus is depicted as a red circle. Protons and neutrons are made up of even smaller particles, called quarks. Since quarks cannot be divided into smaller parts, they are considered to be elementary particles. The electron, which we will talk about in a second, is also an elementary particle. Now let's take a look at what's around the nucleus. In the animation, the electrons are depicted as orange circles flying along the white lines. In reality, the electrons surround the atom in cloud-like shapes called orbitals. The white lines represent the orbitals. At most, 2 electrons can occupy an orbital. It is important to remember that this animation is a simplified version to help you understand the structure of an atom. This so-called planetary model is physically not correct, but it is useful as a simple sketch. There are some words which can be confusing. Nucleons kind of sounds like the plural of nucleus, right? Well, that is not the case, because a nucleus is not the same as nucleons. A nucleus is the center of an atom. Protons and neutrons are nucleons and make up the nucleus. And the plural of nucleus is nuclei. Make sure you don't confuse these words. Of the three main components of an atom, the electron is the lightest. The proton and the neutron have approximately the same mass. Each of them is about 1,800 times heavier than an electron. The unit charge of the electron is exactly the same as the unit charge of the proton. The only difference being that the electron has a negative charge and the proton has a positive charge. Finally, the neutron, as its name says, is neutral and has no electric charge. This will help you understand how small an atom and all its subatomic particles truly are. Let's take an atom and blow it up to the size of our Earth. That means our atom would now have a diameter of 12,800 kilometers. In comparison, the nucleus's diameter would be the length of a football field, so about 120 meters long. If we go one step deeper, a nucleon would have a diameter of about 1 centimeter, the size of a small marble. And lastly, a quark would be the size of a small flea. An atom is pretty much an empty space with a tiny nucleus in the center. Therefore, 99.9% of the atom's mass is located in the nucleus. Alike charges repel and opposite charges attract. Because protons are charged positively, a nucleus made entirely of protons would fly apart due to the electrostatic repulsion. So, what attractive force is holding the nucleus together? This force is called the strong nuclear force and acts between the nucleons. Here you can see two nuclei. On the left, the protons are repelling each other, and on the right, the nucleons are attracting each other. That means there is an attraction between protons and protons, neutrons and protons and neutrons. In reality, both forces are acting at the same time. The strong nuclear force has to balance out the repulsive electrostatic force. Here are, in my opinion, the most important characteristics of the strong nuclear force. Firstly, it is independent of electric charge, meaning there can even be an attraction between two positively charged protons, for example. Secondly, it is strongly attractive between nucleons that are very close together. It's important to note that the force is only attractive within a certain range. So, at a distance of about 1 femtometer, which is 10 to the power of negative 15 meters, the force is the most attractive. This point is marked with a red circle. At distances below about 0.7 femtometers, the force becomes repulsive. How is this force able to balance out the repulsion? Let's take a look at this image. The x-axis stands for the number of protons in a nucleus, and the y-axis stands for the number of neutrons. The red line portrays the condition of having the same number of protons as neutrons. This acts as a reference line. The blue dotted line above represents all stable nuclei. Even though there are a few exceptions, we can generalize and say that the number of neutrons will always equal or exceed the number of protons in a nucleus. The reason why the number of neutrons increases faster than the number of protons is that the more protons one has in a nucleus, the stronger the repulsion is. The larger number of neutrons can therefore counteract the electrostatic repulsion. If a nucleus can't balance out the forces, it becomes unstable and will spontaneously rearrange itself to reach a stable configuration. In other words, nuclei reach stability through radioactive decay. And that is what we'll be talking about next time. Okay, let's summarize what we've learned. Here are 4 important facts that you should remember. Atoms are the basic building blocks of all matter. They are made up of electrons, protons, and neutrons. A force called the strong nuclear force holds the nucleus together. And there need to be at least as many neutrons as protons in the nucleus in order for the nucleus to remain in a stable state. The next time you are brushing your teeth, try recalling what the strong nuclear force is. Repeating the information in your own words will help you remember it for longer. Thanks for tuning in. See you soon!